LD 300 and so on. Now, people start to move into Revit Pre-Cast to build up the LD 400 models. All right. So, if you guys ever experienced to use the Revit MVP fabrications, almost the same. You're converting the Revit models into the fabrication models. So now, Revit Pre-Cast is focused only for the concrete, all right, concrete structure. And at this moment, we only focus with the wall and also the slabs. Okay, so there are a few workarounds. If you guys want to develop the Pre-Cast for the beams or column, I'll touch about the workaround later on. But before that, I want to explain to you guys what is the setting, what is the settings in there and so on. Now, if anyone installed Revit 2018 or 2019, you should be able to see there's one additional tab. Right. Alright. If I don't use mic, can you guys hear me from the back?
No.
Okay.
Make sure you use them because we have a session tomorrow. Okay.
Yeah, I hate anything with the stick. I hate it. All right. So okay, it makes me easier to communicate with you guys with this man. All right. Whoever installed Pre-Cast, you guys will have this kind of extension or the additional tab in your Revit. So the thing is very simple. You can look at that. We already have few tabs, and we already have few functions in there. But it's good and sufficient enough to convert your design model into a fabrication model. So first of all, if you look at it, if you go into the configurations, anything to do with the Pre-Cast, everything will be managed and configured in the configuration tab if you here. Alright. The first part for this session is I will explain what is the settings in there, what you guys need to look about, what you guys need to do. The second part is more to hands-on. I give you two Revit files. One is to show it to the customer, the theories way how you can convert the models, the design model to a fabrications. That one is the first Revit file. Always the theory is not practical, right? So the second one I will show to you the practical way to do that, or in reality how people converting the design models to the fabrication model. I'll explain that more in details later on. Now, let me go back to my slides here. Okay, so Revit Pre-Cast is very simple. From a design model, you split it into a panel. All right, we call it as a split into a panel. You put in your reinforcement and detailings, and then you produce the shop drawing and also the CAM export. All right. If you look at it in the settings in there, you only have two export. One is the PXML, and the other one is the unit technique. All right. Commonly, people are using PXML in the industry. That is what the machine is reading on. Later, you will go through this kind of process as well. Now, who is not familiar with parts as assembly in Revit? Are you guys familiar with the parts and assembly? Yes. All right. Cool. All right. The concept behind Pre-Cast is the same thing. Once you click split, it will create the parts and assembly for you, for each of the components. Alright, that's why you can generate the shop drawings, that's why you can generate the CAM export and so on. Now, as I mentioned earlier, we only focus on two elements at this moment. One is the Pre-Cast wall, and the other one is the slabs. Alright, so later we will go through some of the details. Because of the time limitation, I cannot go through everything in details. I will give you just a general overview of what is going on. Alright? Now, if you look at on your Revit Pre-Cast here, I know the screen is a bit blurred. Can you guys click on the tab configurations there? Alright? Click on the configurations there. You should be able to see each of the components here, like for example concrete and also the slab. We only have three parts. If you look at the concrete wall, you have a solid wall, right? Okay. Under solid wall, you have a part segmentations, reinforcement, and also the shop drawings. Is that correct? Is it what you guys are seeing right now? All right. So each of the components, you have 4 configurations here. Okay. Parts, segmentations, reinforcement, and shop drawings. First thing first, if you look at the parts here, if you click on the parts, you should be able to see. You can select what kind of lifters that you want to use, what kind of connection that you want to use: horizontal, vertical, T joints, L joints, angle. So those kind of the settings or the connection that you want to do. Now, if you look at all those connections here, all right, all those connections here that you can click on it, and basically you can choose all kind of different options over here, right? Like for example, this one. Now, if I go into parts, and if I click on certain element, all right, all the selection here is reading the RFA families file. Okay, so all these families here is not located in your standard locations. The location that you should be looking at is here. If you go to your computer, see program data / Autodesk structural precast for Revit 2018 or 2019, go into the folder, then you should be able to see all the folder structures is in there. You should be able to see the annotations, the families is in there, the shop drawings template is in there. What else? The profile for the connections, all the profiles, everything's in there. All right. So this is a location you should be looking at. See program data, Autodesk structural precast for Revit. Go into the families, then you should be able to see the whole list. All right. Now, up to this stage, any questions? Can you guys find the folder? All right, cool. Okay, so now let's look at the configuration a while. Okay, I quickly do a screenshot for you guys on the settings for the lifters. If you click on the first thing first, if you guys go to your Revit, go to the configurations, solid walls. First of all, if you look at the lifters, if anyone doesn't know what is lifters, you can look at the screenshot that I created for you guys over here. All right. So basically, you can first of all you can select what type of lifters that you want to be. Okay. So similar to all the Revit settings, if you want to create a new lifters, you can create your own families, dump it into the folders that in this location. All right. So how the Revit works is you cannot say that load from library or you want to import into your library. Every time you click on the Pre-Cast tab, it will automatically read in this folder. So if you created any new families or new template, dump into this folder and it should be reflected in your list here. Okay? So,
Question, Casey.
Yep.
Every time I launch Revit, initially, it doesn't have the Pre-Cast families, right?
Yes.
Why is that?
Okay. Every time you show up your Revit, and every time you click on Pre-Cast, it will start to read on this folder. So actually, it's an extension. It's not part of the it's not part of the Revit. It's part of the extension. So every time you put up your Revit, it will start to read all the families and also the settings in this folder. That's why every time it's keep running, you can see there's a bar that is running.
Yeah, and I think one of the reasons why it was built like that is because not all of your customers are going to have the intention of going LOD 400. And do take note that the more families that you load onto a project template, it actually blows up, or what's the term? It bloats the project file. That's why we have the purge or the audit routines there. So again, it's not a bug. It was designed or intended to be that way. That if you have the intention to do detailing for Pre-Cast, that's the only time that it's going to load. I think for Casey, he's gone the other way around, whereas you now have a template that where all of the precast families are loaded because you want to do a demo, right, for your customer. But by default, if you launch a template, the precast families are not loaded because not all of your customers are going to do precast detailing. All right, that's the logic.
So if you guys click on the Pre-Cast tab, you can see there's a bar running, reading all the RFA files and also the settings, right? So that is part of the reason. Now, I will share these slides for you guys so that you guys know all the settings, what is all the settings about. If you look at here, the minimum distance of the edge is starting from the side of the panel to the first lifters. Right, that is the minimum distance to the edge. Minimum top distance to the opening. If you have the wall opening, if you have the door openings or the window openings, they will start to calculate what is the distance over here. All right. So everything I put it into the PowerPoint so that you guys can use the reference. There's one more. If I put in saying that the side lifter if height is exceeded. Let's say that if you have a vertical wall connection or the vertical precast wall connection. So basically they will create all those kind of side lifters for you. Now, in different countries we will use a different type of precast. Some of it is a dry joint, some of it is a wet joint. Alright? Don't ask me what is that. I start to learn what is dry joint and wet joints a couple of months ago because I'm not a structure background. But whatever that you can see here, lifters, joints, bolt and nut, and those kind of connection is considered as a dry joint. All right. Wet joints is more like sealant. They're pouring the concrete in there to close the gap and to join the gap. Those are the wet joints. So now, if you're seeing a customer that they're doing the dry joint, you can use all these kind of method here: lifters, connection, bolt, key joints, and so on. But if they're using wet joints, what you can do over here is you can select the type as a none. Alright? If you look at it from the option here, you can choose it as a none or no joint. It means that it will not generate or it will not auto-populate any joints for you. Alright? So there's an option for you to configure whether you want a dry joint or the wet joint. Now, bracing. Same thing as well. If you want to put in the bracing here, I already put in the configuration, the numbers. Once you get the PowerPoint or the PDF, refer to the image here. Number 3, number 4, number 5 is I put in the remarks here as well. So you can do a side-by-side comparison. What is the setting for the number 3 and number 4? What is the setting for the number 5? So that you guys can play around. Connection sections. If you look at the connection section at the bottom there, you should be able to see there's a frontal, side, key connection as well. Alright, so like for example over here, this one is a frontal. Alright, this one is the side. Alright, and this one is a key joint. Okay, depends on how your precast is being assembled. And depends on the layout as well of your building. Alright, horizontal profiles is based on this one. Alright, you guys know that the male and the female method, right? How they combine these two together. So basically, you can control the profile here. Now, whenever it's reading the profile, you guys know that in Revit family we have a profile. Alright, it's controlled in the same manner as well. Again, go to the program data /Autodesk /structural precast for Revit. Go into the profile folder. All the profiles in there. So if you want to create new, create that and put it into that folder. Alright. Noses, same thing as well. And custom plates. So all the settings is everything is in there. Now, if you go into the segmentations, alright, this segmentation here is for you to configure what is the minimum size or the maximum size for each of the panel, for them to do the auto splitting for you. Alright. So now, normally when we do a Revit model design, we will do a big panel of wall. Let's say that the span is about 5 meters. So So with just one straight 5-meter panel. But in Pre-Cast, it might be splitting into 5 panels, 1 meter each, right? So in Revit Pre-Cast, we can do an auto segmentation. We will go through that later on. So all the settings will be based on here, all right? What is the maximum length, maximum height? Normally in the fabrications, they will have a maximum height, and also the maximum length, and also the maximum height, based on the machines and based on the weight as well. That's why you can see here, we can set what is the maximum weight as well, all right? There's a certain kg that they cannot exceed it because of the transportation and also because of the movable item from one place to one place. So we need to configure that. Now, if you go into the reinforcement, there's a couple of things that you can do in the reinforcement here. Either it's the area reinforcement or the edge reinforcement. I put in some notes at the side here so that you guys can understand what is the corner bars, U bars, L bars, and also the straight bars. Alright? How the edge connection is going to be. Okay? Can I know how many of you here is a structural engineer? 1, 2. So the rest is architect. 3. How many of you here is architect background? IT,
พี่กวีครับ
civil, M&E. Okay, so how many of you understand what is reinforcement, what is bar, what is slabs, everything? So you guys understand? Alright, so okay, what I'm going to do here is later on when Janos share with you the slide, I will put few more description for you to understand what is the structural terms is all about, so that you guys can do a presentation to your client. Okay. Now, these few things here you can do the settings. Shop drawings. So what the Pre-Cast extension is capable to do here is they can automate the process. Once you develop your parts and assembly, it will automatically generate the shop drawings for you. All right. The shop drawings will include the drawings, the schedules, and also some other information. We will take a look on that one later on. Now, I did share 2 files for you. One is called Pre-Cast Element, and the other one is called Pre-Cast Building for TS Summit, right? Now, you guys can quickly open up. There's one model called Pre-Cast Building for TS Summit. Now, this is one of the examples that you guys can play around. You guys can use your own models to develop the Pre-Cast as well. Okay, so the thing is very simple. Part of this building is already converted into a Pre-Cast. Now, I want to ask a question. If I want to look at this model only assembly, what is the settings that I need to change? Anyone? Okay, you guys play with the parts assembly before, right? What is the settings that allows me to change my view just to show the assembly? And what is the settings allows me to change just to see the design model? Anyone? Sorry? Yeah. So you go to the part assembly here, you can change it. If you click on the parts assembly, you should be able to see show parts, show original, or show both. Alright? If you show both, it means that you are showing the design models and also the fabrication models. Okay? So how Pre-Cast works again is they are converting your design models into a fabrication model. Okay? That's why you still have 2 things over here. Now, if I go into here and say that, hey, I just want to look at show original, that means that I'm showing my design models. Okay? And if I change my show parts, it will only show it to me my fabrication models. Okay? So, the thing is pretty simple over here. If you go into configuration right now, click on the configuration, you should be able to see the bar is running. They're reading whatever the families that inside the subfolders and so on. Now, if you go in here, this is where all the settings that you can configure. Like for example, what is the parts, what is the segment, how big the segmentations and so on. Now, I will not go through with you guys on the settings and so on. That one is for you guys to explore. What I want you guys to do here is very simple. Just click on the slabs on the level 2. Alright? If you look at it, this is a Revit component slabs. Right? Now, there's one key point about the precast extension. They only can convert your structural model, not your architectural model. Okay? So this slabs here is not an architectural floor, but it's a structural floor. The wall there is not an architectural wall, but it's a structural wall. Alright? So you guys need to change your architectural model to a structural if you guys want to convert that. So to do that is very easy. All you need to do is just go to the precast and click on the split button. Okay? So remember that we do a segmentation setting just now. Maximum height, maximum length, minimum height, minimum length, maximum weight. So based on that setting here, they will split your models into each of the panel. Okay? So you click on the split. Now they will ask you to choose your setting. Do you want a solid slab, hollow core, or the griddle slab? Those who are using 2018, I don't think you guys have the griddles in your settings yet. 2019 you have that. Okay. Now all you need to do here is choose your type of slab and click OK. What they will do is they will start to split your slab into each of the panels. Okay. You guys managed to do that? Right? Sorry? Floor type? Hollow core or solid is okay. So whichever that we do. Alright, so now once it's done, you can see all the slab is already done. Now my next question to you guys is how I'm going to change my setting to have a vertical slabs change to the horizontal slabs. What is the things that I need to do? Back to the standard, the basic Revit structural type of modeling. How are we going to change the way how the splitting, instead of going for the vertical, I go for the horizontal, or the other way? What is the things that I need to do? Anyone? Anyone? Sorry? Okay. Yep, span direction. So all you need to do here is, you guys can go back to your design models. All right, go to the edit boundary and then change the span direction to the other way. All right. So now you guys will understand that how the Revit precast work is. They will read your span direction and how they're going to cut it out for you one by one. Okay? Now, this is how you can show it to your customers or during presentation, how you can convert your Revit models to the fabrication models. Now, this is theory. It never happens in the actual or in the reality that this is how the thing works. Because most of the time, the fabrications or the fabricator will think that, hey, this is not efficient because this is a wastage. Hey, I don't want to cut it in this way. Hey, I don't want to join it in this way. Because most of the time they have to take into consideration the cast in situ and also other structures as well. Alright? So we have two ways using the precast. One is using the automation, which is the segmentations. The one that you guys click the button split just now. The other way is we are doing the manual way. Alright, we'll go through that later on. But this is how you can show it to your client to convert the models from designs to a fabrication. Now, by the time you guys done it, let's say that I pick one of the example on top here. Right now, once you guys split it up, the second thing here is to put in the reinforcement. If you guys click on the reinforcement tab on top here, there's one button, reinforcement. Alright. Once you guys click on this reinforcement, again they will read all the configuration settings in the configuration tab there. Is it a mesh? How many mesh? Is it 2 meshes, top or bottom? Do you have a center mesh? How is the rebar? How is the hook? So everything will be configured and do the settings based on that. Alright. If you guys are converting to the solid slab, then you can see the meshes is being automatically done. Hollow core, I don't have any setting is done on that part yet. But I can try, what can I do here is, I can do the splitting for this one into a solid slab and show it to you guys. Now I can do that for the wall as well, for the slab. Okay. Now just give me a minute. I'm going to convert that into a solid slabs. Okay. So now let's say that for example I'm going to pick up this one and I go to the precast here and click on the reinforcement. So now once I click on the reinforcement, they will ask you to choose whether is it a solid slab rebar reinforcement or it's a fabric reinforcement. So where do we get all these kind of settings or the selections from? Is from the configuration bar or the configuration tab inside there. Alright, so you guys can go back inside there to make the changes and so on. So let's say that for example I'm going to choose settings saying that is the solid slab rebar reinforcement. At the same time as well, we can click on the edit button to change the settings. Alright, so from here you should be able to see what type of bar size, the diameter that I want to use, how is the settings that I want it to be, what is the distance, is it by numbers, is it by maximum distance, is it by the minimum distance, what is the directions and so on. So basically we can do pretty much settings over here. Now if I go into the second tab, same thing as well. I can say that hey, that one is a top bar and this one is a bottom bar. So we can do the both layering on the meshing and so on. Okay. Now by the time it's done, let's say that I just pick whatever is standard. I click OK. You should be able to see the reinforcement in there. Now once you've done that, if you click on the settings, you should be able to see the whole thing here is an assembly. Right? So I hope you guys understand how the Revit assembly and parts work. Okay. So this is an assembly 324, and if I scroll down my project browser here, you should be able to see there's one, where is it? This one is the 334, it should be somewhere around here. There you go. So everything will be listed down at the project browser here. Now, the next thing what we need to do here is we just need to convert this one into shop drawings. All you need to do here is select the assembly and click on the shop drawing itself. Alright? Now, the settings or the layout of the shop drawings is reading from the template. If you go into the folders, the program data folders, you should be able to see there's one settings for you to configure the layout. And then from there you can do your own settings and so on. Now, once I click inside here, alright, you should be able to see there's sections, 3D, floor plan, top view, and so on. Of course, you can do a setting saying that, hey, my standard settings, I don't want it to be 3D, alright, I can take out 3D and change to a different view. Now, it will give you all those kind of settings as well, including all the dimensions, and also the material takeoff, and also the part list, alright. The material takeoff is based on the concrete slabs that you have created. Now, if I go at the bottom here, you should be able to see there's a rebar. Alright, there's a rebar list here. How many bars that I have it there, what is the total length and so on. Now, if you guys meet up with the fabricator, normally they will concern about two things. One is the total weight at the bottom here. Alright? If you look at bottom here, the total weight here is 11540. This one is the overall weight for the concrete. Alright? But it's not the net. Alright? What do I mean by it's not the net is they are not deducting any rebar locations. So it will calculate the total mass. Alright? By default, the weight at the bottom there, they should deduct whatever the rebar space and so on. They are not doing that. Right now, the weight at the bottom, you can see, is a mass. It's not the net one. Okay? And this is the center of gravity. Normally, fabricator may need this information so that they know that where is the center point in terms of the weight and so on. Alright? This one will be based on your reinforcement locations, the settings, and also the adjustment. Alright? Now, up to this stage, you guys have any questions? Anything? No? Alright. Now, the other thing is quite important to show it to your client as well is on the CAM export. If you guys click on the CAM export, they will export this particular item into a Unitechnic format or the PXML format. These two formats will be sending to the machines to do the automation or the machinery things and so on. Now, basically all you need to do here is you just need to set what is the format that you want to do, PXML or the Unitechnic. Let's say I pick the Unitechnic, PXML, and I'm going to put that on my desktop. Okay, and click OK and generate. Now, it will automatically generate all those information out into a PXML format. Alright, so let me do that again. Alright, so once you guys done that, your PXML file, if you guys don't have the software to open up the PXML file, you can use the notepad to open that one up. Once you open that one up, you should be able to see the whole list is there. What is the rebar size, what is the total length, where is the cutting point, what is the total weight, and so on. I don't know where I put it. Do you guys have any questions so far? You guys okay? Right. This is the thing that you should be showing to your client.